Today we have a new topic of molecular shapes or shapes of molecules. Till the last class we have discussed about bonds in various molecules or between various atoms in a molecule. Ionic bond does not have any directional property, but covalent bond is directional. So they have a definite geometry. This directional property of covalent bond make or give the molecule a particular geometry. Theories of bonding. Actually you have three theories: Vsepr theory, valence, shell electron pair repulsion theory, valence bond theory and its extension hybridization, and molecular orbital theory. First you have to see Vsepr theory. What are the postulates of this theory? Valence, shell, electron pair repulsion theory. Geometry of a molecule is decided by number of electron pairs in valence shell of central atom. Not all the atoms, you have to look into the central atom and you have to count how many electron pairs are there in the valence shell of that central atom. Depending on the number of that electron pairs in the valence shell of central atom, we can predict the geometry of the molecule. That is the first postulate. Since electrons are negatively charged, electron pairs also will be negatively charged. So they will repel each other. So they try to stay far away as possible to minimize the repulsion between them and to attain stability. Valence shell is assumed to have a spherical shape and valence electron pairs are assumed to localize on this spherical surface at maximum distance. That is the third postulate. Since electron pairs can repel each other, there is a question: which pairs repel more? We have two kinds of pairs. Electron pairs which are not participated in bonding are localized on a particular atom, or it is under the influence of a single nucleus, while electron pairs participated in bonding are tightly held together by two atoms or two nuclei. So lone pair repulsion is high, which is greater than lone pair bond pair, and weakest repulsion is bond pair. And also in this theory, multiple bond can be treated as a single bond. Suppose in SO2 we have S double bond or double bond. Actually it is 4 bonds. But in Vsepr theory, this multiple bond is a single bond. This multiple bond is another single bond. So we can count it as 2, not 4. That is possible only in Vsepr theory. It is one of the oldest theory where the concept in chemistry were not completely expanded as today. Next is bond pair size and bond angle decreases with increase in electronegativity of atom connected to the central atom. Suppose we have a central atom A and X and Y bonded to it. When the electronegativity of the X and Y, that is atoms bonded to central atom, increases, this shared pair will be attracted towards them. Then the repulsion between them decreases. When the repulsion decreases, bond come closer and bond angle decreases. That is the point. Now we are applying directly this theory to various molecules with us. But peculiarity of the molecules in first section is they have bond pair only. That means they do not contain any lone pair. In the first postulate, we have stated that shape of the molecule is decided by number of valence electron pairs on the central atom. If number of valence electron pairs is 2, shape will be linear. Example BeCl2. Beryllium, central atom has 2 electron pairs, 2 electron of beryllium and 2 electrons from neighboring chlorine. 1 electron each from 2 chlorines. So these pairs, when placed like this, they will repel. So to reduce the repulsion, to minimize the repulsion, one is oriented here and one is here, or simply they have to orient in opposite direction. So we will get linear structure and bond angle is found to be 180. If the valence electron pairs are 3 in number, shape will be trigonal planar or triangular planar. Triangular planar. Example BeCl3, and structure is shown like this: 1 pair, 2 pair, 3 pair. This shape is called triangular planar. That means all the 4 atoms are in a plane, triangular shaped plane, and angle is 120. Here total angle is 360. It is divided into 3 equal parts. So one part is 120 degree. So it is 180. Here it is 120. Now if third one, if electron pairs are 4, we will get a shape of tetrahedral, just like CH4. C H 2 3 4. Here bond angle is 109 degree 28 minute. All the bond angles are equal. It is actually a 3D structure. Next one, fourth one, if number of valence electron pairs in valence shell is 5, then we can call it as not pentagonal, it is triagonal by pyramidal. Example PCl5. What is the shape? Phosphorus at the center. 3 chlorines are in triangular plane. 1 chlorine at the top, 1 chlorine at the bottom. So it has 2 pyramids, one at the top and one at the bottom. When we draw a line like this, you can see the pyramid. There is another pyramid at the bottom. So it is triagonal by pyramidal. Triagonal means base, and pyramidal, one at the top and one at the bottom. Here bond angle is in plane. Inside the plane total angle is divided into 3 parts. So 1 is 120. In plane angle is 120 and this angle is 90. Angle between axial chlorine and equatorial chlorine. Three chlorine atoms on the basic plane is equatorial chlorine, and two oriented out of this plane is called axial chlorine. This is the structure. Here axial bond length is greater than equatorial bond length. That means these two bonds are weak. So liberation of chlorine is very easy, and PCl5 is a good chlorinating agent. So far we had only one bond angle, but here we have two angles. Inside the plane 120 and outside the plane it is 90. How many angles are there with 90? This is 90. This is 90. This is also 90. 3 bonds. In the same way, other 3 bonds can be expected from bottom. So totally 6 bonds are there with 90. And this bond angle is 180. Cl, P, Cl, that is 180. That is another possibility. Next one, if number of valence electron pairs is 6, then we will call the shape as square bipyramidal. Instead of trigonal bipyramidal, we have square bipyramidal, or other name is octahedral. Example S sub 6. You have to draw a rectangular plane first. Sulfur at the center and fluorines 4 at the corner, 1 at the top, 1 at the bottom. It is square, and 1 pyramid at the top and 1 pyramid at the bottom. Totally we have 6 fluorine atoms. This is also known as octahedral. Since this shape has 8 faces, then octahedral. Here bond angle is, all the bond angle is 90 inside the plane and outside the plane. Both angles are 90. This is 180. How many 180 angles are there? There are 3 FSF bonds angle with 180 degree. You have to identify them. 3 bonds with 180 degree. 3 angles. Then next one is 7. In 7 we have the shape pentagonal by pyramidal. IF7. 1 pentagon and 2 pyramids. First of all, you have to draw pentagon. Iodine at the center. Fluorine 1, 2, 3, 4, 5. 1 at the top, that is 1 pyramid. Other at the bottom, that is second pyramid. Here angle inside the plane is 72 degree, because total 360 is divided into 5 sections. So 360 by 5, that is 72 degree. An angle out of plane angle is 90 degree. And also another example is SO4 2 minus. Structure is S double bond O minus. Which is the central atom in this molecule? Without any doubt, we can say that it is sulfur. And how many valence electron pairs are there in sulfur? It is actually 6. But in one of the postulates in this theory stated that multiple bonds can be counted as single bond. So it is a single bond, it is other single bond, third one, fourth one, totally 4 bonds. So 4 pairs. 4 pairs means shape is tetrahedral. That is the structure drawn here. Now we have to see some other molecules with lone pairs. So far we discussed about the molecules having bond pair only. But when lone pair is also present in the molecule, definitely shape of the molecule will be changed. Example, SnCl2. To predict the shape of the SnCl2, we have to count the number of valence electron pairs in central atom. Which is the central atom? Central atom is tin. Tin belongs to 14 group. So number of valence electron is 4 in tin. And each chlorine donate 1 electron each. Then 2. 4 plus 2 by 2, 3 pairs. For 3 pair, we are expecting the geometry as triagonal planar. Triagonal planar. In notebook, you have to write it completely. Triangular planar. But even if we have 3 pair, we can see 2 atoms. Only 2 chlorine atoms bonded to tin. What actually it means that 1 electron pair is lone pair. We have only 2 bonds. Actually, you have 3 pairs, but only 2 bonds. Then third one will be lone pair. So tin, 1 bond pair, second bond pair, and 1 lone pair. Bond pair and bond pair will repel each other. Lone pair, bond pair also repel each other. But in postulate we have stated that lone pair bond pair repulsion is much greater than lone pair repulsion. So this push from the top to bottom will be higher than the repulsion between these two. Automatically this angle will be slightly less than we are expecting. The expected angle is 120. Since it is triagonal planar, we are expecting 120, but actually this angle is 95 degrees Celsius only because of the lone pair bond pair repulsion. This is the structure of SnCl2. But if we coming to ammonia, central atom is nitrogen having 5 valence electron, and this nitrogen get 3 more electrons from hydrogen, and totally how many pairs? To count the pairs, we have to divide electron with the 2. Totally we will get 4 pairs. But 4 pairs are there, but only 3 atoms here bonding with the nitrogen. So we have 3 bond pair and 1 lone pair. Since it is 4, we are expecting tetrahedral. Expected geometry is tetrahedral, but actually nitrogen, lone pair, hydrogen. Here also lone pair bond pair repulsion is much greater than bond pair repulsion. Again we have a push from the top to bottom. So bond angle decreases to 107 degree instead of 109 degree 28 minutes for tetrahedral. Actually this structure is not tetrahedral. This structure is called triagonal pyramidal, not planar. These 3 hydrogen atoms are in a plane, but nitrogen present on the top of this plane. So this shape is a pyramid, not plane. So you have to say triagonal pyramidal. And also this structure is called bend shape. while stating the shape of the molecule, you need to consider lone pair. So shape is this one, that is a bend, that is bend structure. If you are coming to water, central atom is oxygen, 6 valence electron plus 2 more electron from hydrogen. To count the pair, divide by 2, then again 4. 4 pairs means tetrahedral. But actually we have 2 lone pairs. How you will get 2 lone pairs? Think it. Totally 4 pairs. For bonding we have only 2 hydrogen. So remaining 2 will be lone pair. This lone pair repulsion is much greater than lone pair bond pair. Which is greater than bond pair. So a huge or heavy push can be experienced from the top. So bond angle decreases to 104.5 degree in water, and this shape is HOH. Without considering lone pair, you have this one. This structure is also known as bend shape or V shape or angular shape with an angle of 104.5 degree. Another example is XCF2. Xenon belongs to 18th group, so valence electron is 8 plus 2 more electron from fluorine, and pairs is 5. 5 pair. What actually we are expecting? That is trigonal, planar, not planar, trigonal by pyramidal. Trigonal by pyramidal. To form this structure, we need 5 bond pairs. So, but here we have 5 pairs, only 2 bond pair. The 3 remaining are lone pair. So, shape is trigonal, pyramidal. XC at the center. Lone pair. Where to draw lone pair? Here one lone pair, here one lone pair, here one lone pair, and one fluorine here and one fluorine here. Actually shape is this one. Without considering 3 lone pairs, we have only this one, that is linear shape. From this discussion, it is clear that shape of the molecule is dependable not only on the number of valence electron pairs on the central atom, it is also dependable on the number of lone pairs also. If there is any lone pair in the molecule, if there is any lone pair in the central atom, it will influence the final shape of the molecule. And few more examples are there in the textbook. You can work on it, and if you have any doubt, you can ask me without any hesitation. Thank you.